Welcome to the webinar on data microservices with Spring Cloud Data Flow. My name is Mark Fisher, and I'm joined today by Mark Pollack. Together, we lead the Spring Cloud Data Flow project. And the agenda today will be covering data microservices. And we'll be talking about the role of Spring Boot for building microservice applications, as well as other projects that build on top of Spring Boot. We will be, sorry, I accidentally advanced this slide. We will be talking about Spring Cloud Data Flow, of course, including the deployment SPI that it has as a dependency for supporting deployment to a range of different runtimes, everything from local on your laptop to the cloud. And for roughly the second half of the presentation, we will be doing live demos. So as I mentioned, Spring Cloud Data Flow, at the very foundation is Spring Boot, which is really the foundation for everything within the Spring project ecosystem involving microservices. The idea behind the Spring Boot application is that it's a self-contained Uber jar that includes all of its dependencies. And Spring Boot features support for the full life cycle of development to production, including things like actuator endpoints for checking the health of your application, verifying the configuration, environment properties, and so on, as well as a built-in security that can then be customized. It makes it easy to use Spring profiles to drive different configurations for different environments. And likewise, at the level of supporting the binding of actual property values, there's a wide range of options there that also make these single jar artifacts portable across a number of different runtimes. So running locally, you can pass in properties via command line arguments. You can pass with system properties or environment variables when you're pushing to a cloud type environment. And you can bake in your properties, or at least your default values for properties, with properties files or YAML files that are actually contained within the artifact or alongside it, for instance, in the directory where you execute from. Another aspect of Spring Boot is the auto configuration. And so this, from the implementation perspective, involves a spring.factories file on the class path that simply points to a fully qualified class that contains Java-based configuration. And anytime you have these Spring Boot starters on your class path, then whatever auto configuration those starters bring in will be added to your application context. So this is commonly used for things like middleware, resource connections to databases, message brokers, and so on. All of the projects that we're showing you today are built with Spring Boot. Every one of these projects has a layer that is itself exposed as starters, and then we build on top of those starters to basically compose these applications from those layers. And it's the same experience if you are developing custom applications. So really the key point about building a microservice-based solution is that you are not building a single monolithic application to process data. So we're talking about data microservices being those microservices that are focused on processing data. And here we have an example, reading from the Twitter garden hose and writing to Cassandra. Obviously, you could write a single application that does all of that. It connects to Twitter and reads the feed and then writes each row into Cassandra. But there are a lot of advantages to breaking that up into autonomous units, at least in this case, the Twitter consumption and the Cassandra writing, into two separate applications. Each one is autonomous. Each one can scale independently. So you may have more writers than readers, especially in the case with something like the Twitter garden hose, where you only have a single connection that can be active reading from that, but you might want to have a whole range of writers. So you can manage that independently. That also allows you to isolate failure. And it allows you, probably most importantly, to build composed applications with different pieces, like Lego blocks, creating different kinds of pipelines. If you want to write to HDFS instead of Cassandra, you can simply swap out the second application here but keep your Twitter consumer application running. So that's what we're going to be talking about today, is that kind of a pipeline, these aggregate applications made up of multiple microservices. And one of the important points we like to make is that microservices, even though most people think of microservices probably as web apps that are REST-based APIs being exposed, and microservice aggregates are composing applications between, edge services and back-end services that are all communicating with REST, using load balancers and circuit breakers and all of that. And of course, that's an important part of microservice architecture, but it's also possible to build microservice applications that communicate with each other via messaging middleware. Those message middleware options could include more traditional brokers like JMS, where you have queues and topics, or this new generation of stream-oriented publish-subscribe brokers like Kafka. When you're building a message-based solution, you get things like load balancing and even partitioning as a first-class offering within these stream-oriented brokers. There's persistence at the level of the topic, which allows you to have temporal decoupling as well as physical decoupling of your applications without having to worry about those interaction patterns that you have with stateless REST-based microservices. So there's a lot of this support for the load balancing and the failover and the ability for applications to go offline and come back online, rolling upgrades, all of those types of things when you're building with a message broker based solution. So if we revisit the previous slide, just adding one component here, we have the message broker as the way that we're communicating between Twitter and Cassandra. And as I mentioned earlier, we could scale up to have a dozen of these Cassandra writer applications, and they would basically be connecting to the single topic that the Twitter application is writing to. But that gives you the capability to do load balancing or even partitioning, depending on how you have that configured. So these are boot applications, as you can see from the icon. We would have the Twitter app as well as the Cassandra app as self-contained Uber jars with all of the configuration properties, things like Twitter consumer key, consumer secret that you would need to be able to make that connection to the garden hose feed. Those would be configuration properties within boot so that you can pass them. In this case, if we're running locally, you just pass them as environment variable, as command line arguments. If you were going to do, they push these same jars to Cloud Foundry using CF push, then you would set those as environment variables instead of command line arguments. Or you could bake them into the YAML or properties file of the application before you deploy it. But it's the important point there is that there's a single portable artifact. You don't have to build a different artifact for every target runtime environment. So the question is, how do these actually connect to each other? How do we manage this message broker between the boot applications? And that's where the Spring Cloud Stream project enters the picture. So Spring Cloud Stream is itself boot-based, so it supplies auto-configuration support for the message brokers, whether you're using Kafka or you're using Rabbit or you're using Gemfire. It's just a matter of providing the starter for the corresponding binder within your POM, and that auto-configuration kicks in. Another auto-configuration element of Spring Cloud Stream is the binding itself. So based on some properties that you pass, you can bind the output channels or the input channels, depending on what type of a component you have, whether it's acting as a source or a sink. Those bindings will be mapped to a topic name, and there we use an abstraction called the binder in Spring Cloud Stream that would be either backed by an implementation of Kafka, Rabbit, or Gemfire. And that binder SPI is something that can be extended to other message brokers in the future. What that means is, from the developer's experience, you basically are interacting with components that are injected into the application context for you. The developer does not need to configure the component. If you're using Spring integration message channels, then that will be injected into your application context. If you're using a reactive model with either RxJava or Reactor itself, then you would have observables or Flux objects, respectively, that are passed into your application. So all you have to do is implement the logic that actually interacts with those components. And the features that are supported then through this model that we've made as a common model across the various implementations of this abstraction are, as I mentioned earlier, really based on the Kafka model. So you have a publish-subscribe, semantics with consumer groups. So a single publisher can write to a topic, and you can have multiple consumer groups downstream from that topic. Every message that's sent to the topic will arrive at each of those consumer groups. Within a consumer group, you could have multiple instances, and then they will either have just round-robin load balancing or actual partitioning if you provide a property that specifies what key you want to partition on. So that's the model. If you're familiar with Kafka, we've basically mapped that directly to Kafka in our Kafka implementation of the binder, and we've mapped those concepts onto Rabbit for the Rabbit implementation of the binder. And the other project that is that Spring Cloud Dataflow builds upon is called Spring Cloud Task. And here, as opposed to streaming applications that run indefinitely until you undeploy, a Spring Cloud Stream application will be running. A Spring Cloud Task application is intended for anything that is finite processing. So maybe you're moving data from point A to point B and a finite amount of data, file systems, databases, and so on. It might be something that you schedule, but each execution is a finite process, which means you expect it to complete. If successful, you want to know that it was successful. If it fails for some reason, you want to know that it failed, and you might want to cancel it. So it's a little bit of a different life cycle. Whereas stream apps, you deploy a stream and you undeploy a stream. With tasks, you will launch the task and either wait for it to complete or cancel it proactively if you want to. So the Spring Cloud Task project is, again, a boot-based project that brings, for auto configuration, it brings in a task repository that basically records the execution status of your application. And it could be anything. It could be simply printing out hello world and then it exits successfully, and you would be able to go back even after that process is gone and check the database to see the exit status of your hello world application. It could be something that runs for several hours, and you would be able to, again, record the exit status of that through the database. And that's a configurable data source, but it's boot-based, so there's no code necessary. There's not even, the developer doesn't have to create the bean definition or anything. That's what Spring Cloud Task provides if you have it as a starter. And the next topic is basically, sorry, it seems to be a, okay. So Spring Cloud Dataflow, sorry, I was waiting for the slide to update. Spring Cloud Dataflow is an orchestration layer on top of Spring Cloud Stream or Spring Cloud Task applications. So you can deploy streams and tasks within a Spring Cloud Dataflow server instance, and there's a pluggable SPI for where those applications are deployed. I'll be showing demos initially that are running locally, simply spawning JVM processes on my laptop. And then Mark Pollack will be showing some demos where he's deploying applications on Cloud Foundry with the Cloud Foundry-based implementation of our deployer SPI. The experience for the user is the same at the level of the shell and the UI and the REST API. So you have this portability because of these boot-based artifacts that can run on those environments, and then our deployer SPI simply negotiates with the runtime how to launch tasks, how to deploy stream applications, how to scale, and how to shut them down. So there are a number of use cases that you can support with this. There's the basic data ingestion in the Twitter case, writing directly to Cassandra, writing directly to HDFS, just to grab the data. Obviously, there are many other types of sources. You could have a sensor type application where you're reading data via an HTTP endpoint and writing it to some database. You may be doing real-time analytics on that data as it's being fed in, either in addition to storing it somewhere or exclusively, if that's the only purpose for your application. So there you could be just counting things. You could be recording the number of occurrences for a given value, which we'll see in a moment with Twitter hashtags. And then the data import-export use cases typically apply to the Spring Cloud task application. So that might be a case where every hour you pull a file directory or an FTP source and check for data, and if it's present, then you load that into HDFS. Or it could be periodically pulling a database table with the JDBC source and then writing that to, again, HDFS or some non-SQL, NoSQL database. So a number of different options here, and obviously this is where that composability of the various microservices to create different kinds of pipelines really becomes powerful. Okay, and so we have with Dataflow this DSL that's inspired by Unix pipes and filters. Basically what you do is you define a stream where the tokens in the stream are going to be the names of applications that you've registered. So in this case, Twitter Stream and Cassandra are two Spring Cloud Stream applications that you want to run, but you want to run them together. You could do that directly at the jar level because they're just boot apps. So you could do Java-jar Twitter Stream, as we saw earlier, Java-jar Cassandra, and pass in all the properties that they need. You would also need to pass in their binding properties that Spring Cloud Stream uses. So telling Twitter Stream what topic to write to, and telling Cassandra which topic to read from, and what the consumer group name it should use when reading from that. This is the type of stuff that Dataflow will handle for you. So anywhere you see that pipe symbol, that actually ends up translating to a few different properties that are going to be passed down from Spring Cloud Dataflow to the underlying runtime, depending on which deployer SPI it's delegating to. Okay, and at this point, I will hand it over to Mark Pollack to discuss the range of runtime options and their features.
Yep, thanks, Mark. So over the past couple of years, there's been quite an explosion of runtimes in the ecosystem. There have been Apache Yarn and Cloud Foundry as examples of a runtime on a big data platform and as well as a PaaS. But now there's quite a lot of newer ones that are gathering attention, such as Kubernetes, Apache Mesos paired with a framework such as Marathon. Docker Swarm has a similar platform. HashiCorp has Nomad. And part of the reason we've designed Dataflow the way it is to take advantage of these runtime platforms natively as compared to what we had done previously with the previous version of this product called Spring XD, where we developed our own runtime. And having our own runtime meant that we had to have a lot of functionality that was responsible for keeping applications alive, meaning if they failed, we would have to relaunch them. We would have to scale them up, scale them down. And during the course of customers using Spring XD, they started asking for various requests and features which are available on these platforms. So instead of us deciding to continue to do, essentially compete with these ecosystems, we decided to adapt and in turn deploy applications onto them so that the data pipeline would be composed of a series of applications orchestrated onto one of these runtimes. So some features that these runtimes have that are common and shared, resource allocation. For example, this means how much memory would you like to assign to a given application. Certain processors that you might have in your data pipeline might consume more memory than others, and you want to set that on an application per application basis inside the data pipeline. Scaling up and scaling down, that's an important feature, and they all support that. Load balancing. If we deployed an HTTP source in our previous version of the platform, we didn't have an automatic load balancer. You had to set that up manually. However, these platforms take care of fronting your applications with an HTTP load balancer, which is quite useful in many instances. Health monitoring and redeployment I mentioned. And then there's a variety of features that are sometimes unique to each platform that you can end up taking advantage of. So, for example, in Kubernetes, there's a means in the platform to shuffle through changing the application from version 1 to version 2. That might be something you're interested in doing once you've deployed your data pipeline using Spring Cloud Dataflow. So from a 10,000-foot view, there's a Dataflow server, kind of a core, that provides the REST API that you can interact with through curl, or you can interact with that through the shell, which is usually the primary means that we demonstrate creating streams. And there's also a new UI called Flow, where you're able to create visually in a drag-and-drop interface these data pipelines. So all of them talk to the Dataflow server through the same REST API, and the REST API is responsible for taking the incoming request of the DSL description, parsing it, and then figuring out which individual applications it should deploy and with what properties they should have. So it's delegating to a deployer, service provider interface, and we have a variety of implementations, basically 4 of them: Cloud Foundry, Apache Yarn, Apache Mesos, and Kubernetes. So the same interaction in the shell and the UI can be portable across all of these target platforms. And if you're interested in contributing one for your platform of choice that doesn't yet exist, it's fairly straightforward to do. You could look at the GitHub repo for the deployers. That has a link at the end of the slide deck, and get familiar with the deployer SPI to do that. So here's another view showing a bit more of the moving parts in the architecture. So we have the Dataflow server, and sort of below this diagram would be the REST endpoint. And then at any given moment, you have one of these deployer service provider implementations inside the Dataflow server connecting up into the platform. So for example, suppose we're connecting into Cloud Foundry. Cloud Foundry has a managed message broker, Rabbit, and we would deploy 2 applications if a stream consisted of Twitter stream, pipe, Cassandra. What's important, though, is that we can rely on the platform to keep these 2 applications up and running, specify their resources, and define properties for deployment that can be used to indicate that you'd like to run 2 of them, 3 of them. So that's what the second line shows, basically that we're requesting the platform to make sure that 2 of these Cassandra applications are running at any given time, given the logical definition that shows the data flow going from Twitter stream into Cassandra. So this is a box diagram of sort of all the components that we have. You can actually jump into this diagram, bottom up at any level. You can obviously create Spring Boot applications, create Spring Batch applications, Spring Integration applications, just as you've already done. But we've simplified the programming model for stream processing by introducing the Spring Cloud Stream project. So there you can create Spring Cloud Stream apps. They can do whatever you like. You can deploy them however you like. And there's nothing preventing you from just sort of stopping your journey for stream processing at that level. But what we do is we go beyond that because there are a lot of common use cases, for example, data ingestion. And so there's a project, Spring Cloud Stream applications or /modules. We're in the middle of renaming it, so this slide is a bit dated, where we provide many, many out-of-the-box applications. So I'll have a link for that in the next page. So you don't have to build them yourself. So then those applications in turn get mapped onto elements in the DSL, and you can compose them. You can then deploy them. You can set all the properties you might like around resource users and count, instance count, and deploy that portably from your local desktop to the variety of different cloud platforms that you can see here. And the view on top of all of this remains consistent through the shell, the UI, and the REST API. So if you've used Spring Initializer from the Start Spring.io page, the development experience is very similar for Spring Cloud Stream applications. For the ones that we've developed out of the box, they're application starters. And let me just see if I can go there. Here, not that one. There you go. That's the GitHub repository for it. You can see there are a couple dozen of these and categories. Oops, lost my place here. There we go. Okay. And we, in addition, publish Maven artifacts and Docker images on Docker Hub for these out-of-the-box applications. If you want to customize them, you can go to a website that lets you pick which of these out-of-the-box applications you'd want, the binder, and generate basically the code for you to customize and take it further. For example, common cases, you might want to include a JDBC driver for Oracle for your task, and the JDBC driver for Oracle is not open source, so we can't distribute it. But you can then basically create your own application off of our application starter. Similarly, you don't have to use any of the stuff that we provided out of the box. You can create a stream application right from the start, just going to the Start Spring.io page and selecting Kafka Stream or Rabbit Stream. And what this lets you do is you can have applications that are as fine-grained or as complex as you need. So if you have the Cassandra writer, for example, suppose you want to do some transformation before writing the data into Cassandra. You don't necessarily have to deploy another process just to do the transformation. You can create your own custom Cassandra sync that in addition adds the transformation logic into that application so that you could avoid creating another hop on the message bus or the messaging middleware just in order to do some maybe very basic cleanup as you're ingesting the data. So check out those links afterwards if you're interested in getting started customizing things more. And there's a special type of stream. Instead of it coming from a source, it really is coming directly from a topic. And so in the previous example, and what Mark will show, we had a stream called ingest, which was the Twitter consumer being piped into the Cassandra sync. So Twitter source, pipe, symbol, and then Cassandra sync. What we can do is we can use this colon syntax to say, off the ingest stream, I'd like to get the topic that comes right after the Twitter consumer. And I now like to direct that to be consumed by a sync that we call a field value counter. And we provide several counters that let you do kind of lightweight, sort of NoSQL-like analytics. A lot of the analytics that you can do with NoSQL databases revolve around counting things. And this gives you a really great first impression into what's going on in the system. For example, you can count in the tweets how many languages there are of a given type. And we go a step beyond that in the sense that we just don't store this information, for example, in Redis, but we provide a set of REST APIs that allow you to easily embed a dashboard or your own custom UI code to visualize that. And the Spring Cloud Data Flow admin UI provides a simple dashboard to let you visualize these counters, but you could just as easily call out to the REST API to get this counter information in sort of any dashboard technology that you prefer. So with that, I will hand it back over to Mark, who will start to go through some of the demos, and then I'll pick it up after he finishes going through his part. Take it away, Mark.
Okay, thank you. So I'm going to begin with what we typically use as our Hello World example. I'm actually running here the Spring Cloud Dataflow server that is using the local deployer SPI implementation. So that just means it's going to, when I create a stream, the applications within that stream are going to be launched as local processes on the same machine. The example that I'll show is using the, let me start the shell here. I'm going to use the time source, which simply emits a message every second, and the log sync, which simply logs whatever it receives. So you can actually get the list of applications running module list. This is all about the change before our next release, where you see module, we're changing terminology to app. It's being managed within an app registry, and we're referring to these as the Spring Cloud Stream apps, Spring Cloud Task apps. But here you can see that we have sources, processors, and sinks. When you're running the local server, it does load all of this up automatically by default. You can disable that if you want with the boot property, but it's the only server implementation that comes with applications preloaded, because we treat that as our development environment. Since no one is probably ever going to need all of these apps in their own use of Dataflow, the other sort of production runtime environments do not have out-of-the-box applications, but we make it really easy to register those applications. You just need to point to the Maven artifact coordinates, or if you're running with the Kubernetes, for instance, runtime, you would point to Docker artifacts, and we support that through Spring's resource abstraction, either Docker or Maven. Okay, so those apps are preloaded. I'm going to create a stream here using time as the source and log as the sink. So that created a stream, didn't yet deploy it. I can run the stream deploy command to launch that. And then here I will actually, what we'll do is, you can see in the console, it gives us the location of the file. So I can grab the standard out from the log sync, and the log sync is using a logger to write whatever it receives. And since the default for time is to emit a message every second, we should see as soon as this starts, it connects to Kafka, and now it's sending a message. It's logging a message every second. Okay, I can undeploy that stream, and that will stop logging. In fact, I can destroy the stream and recreate one very similarly, but to show how this pipes and filters API works, I will pass fixed delay equals 3 seconds, and log, I can change the level to warn. So if you're creating custom applications, these are just the names of boot properties of that application. I'll show that in just a moment at the code level for these guys. I can use the -- deploy for that to deploy automatically. And then this time we have logs here. And it should be logging every 3 seconds now. Okay, and you can see these are 3 seconds apart now. So that's how you pass in the values. And also the log level itself is now warn, whereas before it was info. So what's actually going on here? If we look at just Java processes I have running on my machine, we've got the time source jar, that's the boot app, and the log sync jar. I can also get a little bit of information about these guys. So this actually also provides the location of log files that I retrieved out of the Dataflow console, but it also gives me the URL. So we can look at this URL and go into browser. I can do /beans, for instance. This is the boot actuator endpoint. So I'm now looking at that process that I executed, and I see what beans are defined in there. Somewhere in there, I should see the time source. Right, there's the time source Kafka application bean itself. If I go to the env endpoint, I should see the binding output producer. You can see it's using the demo topic for binding, and that was passed directly via the deployer SPI. from the Dataflow server. So that's the process that's running there. If I were running with a different implementation of Dataflow server, then these apps would be deployed wherever that target runtime is for the one of the cloud-based runtimes, and you would get the URL for that application on its runtime as opposed to being here on localhost. Okay, so let me just quickly show what this code looks like as well. So you get a sense of the programming model. If we look at the time source, first thing I'll show is actually the POM. So this would be, if you wanted to create your own application, you would do it the same way. You basically have the Spring Cloud Stream Apps starter, and in here we have the Spring Cloud Stream app, and the Spring Cloud Stream app itself will be generated for both Kafka and Rabbit binders. So those will be added via starters as well. So the code, it looks like this. This is actually the time source. All of the code is basically, the important thing is this one line. It's actually emitting the current time with a format that is provided via boot properties. And it's doing that based on a trigger configuration, which provides the properties like fixed delay that I set. The format is now a property here, and this is using the Spring Boot at configuration properties annotation. So that's the extent of code that was written to create this time source. Obviously, it's a trivial thing, but it's very simple to do that. This is really the key part from Spring Cloud Stream is at enable binding. That is where it's telling it what type of channel should be created by the application and injected into the context. So we will have a source channel or the source interface defines an output channel, which is what a source writes to. And then on the sync side, you would have a sync.class, which is an interface that defines an input channel. That at enable binding is what creates all of the underlying infrastructure, whether it finds a Kafka binder or a Rabbit binder. It will create the underlying channel adapter components from Spring integration, set any boot properties on those, and then create a channel instance that is injected into your context that you can use as you normally would if you were building a Spring integration application. I'll just show you the log sync application part, because that's slightly different since it's a sync. It has the @service activator annotation on its method where the messages are going to be received through the sync.input channel. And again, it's using boot configuration properties for the level and the expression that you use and the name of the logger itself. That's kind of a quick example of what this code looks like if you're building one of these applications. At the end, there's already been a couple questions, so at the end we'll talk a little bit more about how this compares with Spring XD, but this part is really the most significant difference. We have this purely boot-based programming model. Everything is Java config-based. There's no XML. There's much less code. It's very easy to write unit tests for these. We have test support classes that will inject those channels that you can use in your tests, and it's very easy to create an application that way. And of course, since they are boot apps themselves, you can run them directly, not only through Dataflow. Okay, so let's get back to the shell, and I will run through the Twitter example that we talked about. Let's see here. We have, I'll create a stream called tweets, and the definition for that will be starting with the source, which is Twitter stream, and then writing out to a file. In this case, I will specify the directory and the file name. Okay, and then when I deploy this, because I need to specify the consumer key and the consumer secret, I will pass the properties file locally where I have that information. Otherwise, I would have needed to pass them in using, I could pass the consumer key and secret like you saw on the slide, just using --, and then they get passed along as boot properties. But this allows me to refer to those in a properties file instead. And then I don't have to include them in the shell commands. Okay, and that says it has deployed, so let's just create this file and then tail it. And while we're waiting on tweets to start appearing in that file, we will also create the tap. So we're doing pure ingestion here of tweets into the file, but we also want to do some counting of the various hashtags. So we'll create another stream. And this one will use the syntax that we saw on the slides to read from a topic directly. And we will use the field value counter as a sink. Okay, so by using that colon in the syntax, it basically allows me to just refer directly to a topic. And I happen to know that that's the topic that was created when Dataflow deployed this app because it uses the stream name and then the name of the app within the stream. I could have gone and created my own, just colon foo, and that would have used the Kafka binder to create a foo topic, and then I could create more different kinds of pipelines that are not necessarily linear by using that as this in the source position for multiple other downstream streams. So the syntax can be used in either the source or the sink position. Okay, so I'm going to deploy this one directly. We can see in the upper right-hand corner that the tweets are now being written to the file. I'll start scrolling by. I'm seeing a lag in the view, but those are scrolling by. And now I can deploy the hashtags. And the field value counter is by default going to be storing its entries in Redis. So now I can display those through the REST API. First, I'll just check if there's anything populated yet. Not quite. Okay, now I'm seeing that the hashtags field value counter has some data. So I'll go to the UI. And in the UI, I will see the streams that I've created so far. And if I don't want to use the shell to manage their lifecycle, I can do that within the UI as well. I can undeploy, redeploy, and destroy streams here. Mark will also show the UI we have for creating streams in the latest version. So there's actually a UI that you can use to visually create your streams. I'm going to go right now to the Analytics tab. Actually, before I do that, I'll show you that on the Runtime tab, we have the same thing that I was showing earlier. So for instance, I can look at where the log files are being written and the URL for this application and so on. If I go to the Analytics tab, I can choose from field value counters. I'll select hashtags. And then I will choose the bubble chart display. And I will get a view of my hashtag counts as they're coming through. And so this bubble chart is showing the most popular items with the largest bubbles. And that's all from what's provided out of the box if you're using our applications, the field value counter specifically. This dashboard for visualization is included in the UI out of the box, so you get that. But there's much more that can be done with analytics, either using our components or building custom ones. That's a big topic of its own. Okay, but now I will hand it back to Mark to go into some demos that show the deployment to the cloud.
Cool, thank you. Okay, so let me make sure that, oops. Yep, all right. Everyone's seeing it. So what I have here is a Cloud Foundry installation where I've already loaded the data flow server for Cloud Foundry. If I pop on over here, you can see the UI for this app. There's no streams at this moment. And in my space, I have Redis, MySQL, and Rabbit. By default, when the data flow server for Cloud Foundry is deployed, this default configuration is to use Rabbit as the binding for communication. This is done through environment variables. So a few environment variables get set over here. I won't show them all, but basically some configuration to bootstrap the data flow server. So I can pop into a shell here. I'll just run the latest one. And here you see server unknown because there's no local data flow server running. We have to specify where it's living. So we're going to point to where it's living on Cloud Foundry. And now get the same type of information that there's no streams. I've installed a bunch of applications already. And what we'll do is we'll create a stream which will ingest data over HTTP and write it into JDBC. So if I create stream, oops. Let's do 007 to be fun. So HTTP is the source. JDBC is the sink. I'm going to give it a table name, which is names, and the columns are going to be name. So what I intend to do is post JSON that has a field with a key name, and that will be inserted into the table called names. I've already created this table ahead of time over here with this little browser for the database. You can view the tables, and then down here is the name table with the name column. And at the moment, there are no names in there. If I execute this SQL, at the bottom here, nothing comes up. So that's the logical definition of the stream, but I want to deploy it. And in particular, I want to tell the JDBC sink to bind to a specific service, namely, whoops, go back over here in my space, namely the one I have called MySQL. So I'll do stream deploy. So I specify this by saying module. This is in the process of change to be called app. So then Spring, whoops, Cloud Explorer. And so I specify the services as MySQL. This is also the place where you specify additional disk or memory requirements that you have. So that's going to go off. And if I look at the CF command line, you'll see that the HTTP application and the JDBC application are starting up. Here I can take a peek at the HTTP one, look at the logs. So it's downloading the build pack at the moment. I will open this sort of more streaming view of tailing the logs. It's creating the droplet and uploading it. And soon we'll see the start of the, let's say, the HTTP source. In the meantime, I will just get ready to post some information to it. There's a shell command that makes it easy to post data to an HTTP endpoint. And so you can see it started. If I go back to here, you'll see this is the endpoint that has the HTTP source. Copy that. And I'll type in some data, backquoting of the field and key value pairs, colon. Also an option to pull this from a file, which would probably be a bit easier. Oops. Oh, I forgot to put HTTP. No equal sign. There we go. So it received it, and if I go back now to the little SQL browser, you'll see Richard appears in the bottom, and I could obviously post more data here. And it'll all just pop in. And so now one thing I can do is, well, we don't have a command yet in the shell to scale. We will eventually. You could go directly to the CF command line and ask it to scale, for example, the JDBC application. Create 2 instances. So number of instances 2. And now you'll see this say 2 instances. I go to the UI here. You'll see 2 instances should be deployed. Yep, there we go, deployed 2 of those. We'll have in the final GA release more monitoring on this view of the messages per second and the rates. So basically now we have 2 of these applications in a consumer group, and they're going to be sharing the flow of messages equally, even though this is obviously me typing stuff in, and it's not a very high rate. But Thomas, and so on. So there you go. Thomas came in. There you go. So there's 2 of them. And so then one other thing I could show here before going back to the slides is I will just bring up the local data flow server, so we don't have to wait as long for deployment, and the local data flow shell. Okay, so that's started. Okay. And here I'm showing the UI that also includes creating a stream with a visual editor. So on the left, you have there are sources, a lot of sources, sinks, and processors, right? These are very interesting ones where you can just type some code in a text box and do transformation with them, then a bunch of sinks. But just for right now, I'll look for the time source. You can drag this over here. If you click on it, you can, edit the various properties that are appropriate for the time source. I'll get the log sync, put it over there. They're not happy because they're not wired together. So I just wire them together like that. And then you can say create stream. Create it and deploy it. Now if I go back to here, I can look at the log, standard out. Oops. I'm going to grab that guy. It is going. There we go. So if I cd to that directory, you'll see the time just flowing by. So there's a lot more to this UI, but just wanted to give a little sort of sneak preview of it. It'll be very useful as well for monitoring because we can look at the view visually to get indication of the message rates as well as the number of instances and things of that nature. I could destroy it here just as well. Okay, and now let me shoot back over into the slides. Okay. So let me, is that working? There we go. So our roadmap, I think someone was asking that question earlier. We have made a few milestone releases to date. We plan to go GA in a couple months. We have one release candidate, about a month time frame. And what we're looking to do afterwards is, in order to benefit from, I guess, the general ecosystem of tooling that we have around microservice applications, we look to closely integrate with a couple things. One of them is Spinnaker, which is a project from Netflix that we've been contributing to along with Google and Microsoft. And this lets you manage the deployment, sort of a continuous deployment tool of how you would go, for example, from version 1 of your processor to version 2, but doing this in a very controlled way in terms of scheduling when you would like to upgrade from version 1 to version 2, but also controlling it based on, is the health of version 2 adequate to continue replacing version 2 with from version 1. So it would look at the health and determine, yep, it looks like version 2 is going okay, and you could automate that, and obviously you could do it manually, but the goal is to automate as much of this as you can. Similarly, the other integration points which are important is next webinar is going to be on Zipkin, which is around distributed tracing. So we'll be able to benefit from the functionality being delivered in Zipkin and the associated project Spring Cloud Sleuth to give you a distributed tracing view of the data that's flowing through your pipeline. So in summary, we're able to build these pipelines that are essentially Spring Boot applications that on top of them have an API that's suitable for doing stream processing through the Spring Cloud Stream Processing. We haven't shown much about Spring Cloud Task. That was a previous webinar, so definitely recommend you check that out to see what's available with Spring Cloud Task. And then Spring Cloud Dataflow really provides the orchestration, namely that you define in a simple DSL syntax how you would like the data pipeline to flow, any sort of taps or secondary streams that you'd like to have to perhaps analyze the data or perhaps send it to another sink for storage. For example, maybe you want to send it to both Cassandra and HDFS. And obviously to specify initial properties such as the memory size, the disk resource size, the number of counts. So once that is done, then the apps are off and running, and we can start scaling them and managing their versions and their lifetime. And in particular, do this in a portable way so that we're able to run anywhere, really on any major cloud platform. So these are the main links. If you go to the data flow link, you'll in turn be able to hop to the individual data flow servers for Cloud Foundry, for Kubernetes, and so on. And installation is basically doing a wget of an artifact in our repository for the server, a wget or curl for the shell, and then follow the getting started guide in the reference docs. If you want to look a little bit deeper into what's going on in the deployer, the Spring Cloud deployer GitHub URL is there. Feel free to poke around and post any questions or comments there. So I think with that, we can look to see if there are any unanswered questions. I'm sure Mark has been
I think we managed to
diligent.
Yeah, he's been great. Yeah, he's been knocking them all down, and there's a lot of them. Yeah, I think he actually just answered the last one, so we're good. Folks, if you do have any last questions, now is the time as we just kind of wrap up the webinar. As Mark said, actually, if you could go back one slide, Mark, that would be awesome for your all your links. So you heard Mark on getting a hold of bits. So instead of going to the usual Maven and Gradle, use wget or curl to pick this stuff up. And then, Mark, if you wouldn't mind going forward one more slide. The links for those are also in the resource tab of your ON24 user interface. So if you go down to the bottom of ON24, the screen you're looking at now, you should see a tab there called resource. So I encourage you to just kind of click on that and crack open some of those tabs in a browser, separate browser window or browser tab, because they will go away as soon as we disconnect the webinar. So, and then if you want to kind of stay on top of what's happening with Spring Cloud Dataflow, there's lots of, you can see some of our social URLs there. We post about things frequently, blog posts, other webinars, and of course, we are going to be covering this in a fair amount of detail at Spring One Platform, which is our annual user conference located in Las Vegas, August 1st through 4th. So there'll be quite a lot of focus on Spring Cloud Dataflow at that time. We highly encourage you to go to springoneplatform.io and consider registering. We are some discounted pricing is going to be in effect for a little bit longer. So good time to go register and secure a lower priced ticket. And the ARIA venue in Las Vegas is pretty killer. And of course, Mark and Mark are going to be there along with lots of the other Spring team and community leaders. So really just a good opportunity to get into this. Let's see. So we talked about bits. Yeah, I think that's the big stuff. Thanks for all the time, the questions, the interactivity. And yeah, please do go ahead and grab your links from the bottom of that resources tab now before we close it off. Mark, anything you would, excuse me, actually, before we do that, I forgot to mention, if you were interested in today's webinar topic, I think there's a decent chance you're going to be interested in the June 30th webinar topic, and that is understanding microservice latency. This is an introduction to distributed tracing, Spring Cloud Sleuth, and Zipkin, and that's going to be led by Adrian Cole, who's one of the leaders in the Zipkin community, and also joined by Spring engineer Marcin. I'm not going to try to pronounce his last name unless, Mark, you want to help me with that because I think I'm going to get it wrong. But that is on Thursday, June 30th. Also, a link for that webinar to register for that webinar is also in the Resources tab. So if you're wondering what that was, that is why. And I think it also is a very good topic for those of you who are considering microservice architectures. Okay, I think with that, let's wrap it. Mark, anything you would like to say before we call it a day? And thanks again for doing this. This is fantastic. I'm excited to hear more about the Spinnaker integration and just, amazing how quickly you guys are cranking out features now that, you don't have to build all the sort of non-functional requirements and you can leverage the platform. It's really amazing. I think it's really going to really show up in terms of the value that Spring Cloud Dataflow can add, and it already is showing up.
No, nothing to add other than try it out. Get in touch with us via GitHub issues if you run into problems or have other requests or questions. Also, Stack Overflow is pretty good. I don't know if we have a hashtag there yet. I think we do.
In process. That's
okay.
coming.
So GitHub is the way.
Yep. The only thing I would add is that we will cover through blogs and definitely at Spring One platform more information about the migration from Spring XT to Spring Cloud Dataflow. I know there were some questions about that, and we didn't have a chance to go into too much detail, but we will be releasing more on that in the future.
Thank you, everyone. Appreciate you joining, and have a great day. Take care. Bye-bye.